Buenos días. Vamos a continuar con la lecture of Nicolás Tesla. The general plan is to charge condensers from a direct and alternate current source, preferably a high tension, and to discharge them disruptively, while observing well-known conditions necessary to maintain the oscillation of the current. In view of the general interest taken in big frequency currents and effects producible by them, it seems to me advisable to dwell at some length upon this method's conversion in order to give you clear idea of the action. I will suppose that a continuous current generator is employed, which is often very convenient, indesirable that the generator should possess such high tension as to be able to break through a small air space. If this is not the case, then auxiliary means have to be resources to some on which we will be indeed the case subsequently. When the condensers are charged to a certain potential, the air or insulating space gives way and disruptive discharge occurs. There is then a sudden rush of current and generally a large portion of accumulated electrical energy spent itself. The condensers are thereupon quickly charged, and the same process is repeated in more or less rapid succession. To produce such sudden rushes of current, it is necessary to observe certain conditions. If the rate at which the condensers are discharged is the same as that in which they are charged, then clearly in the assumed case the condensers do not come into play. If the rate of discharge is smaller than the rate of discharging, then again the condenser cannot play an important part. But if, on the contrary, the rate of discharging is greater than that of charging, then a succession of rushes of current is obtained. It is evident that if the rate in which the energy is dissipated by discharging is very much greater than the rate of supply to the condenser, the sudden rushes will be comparatively few, with long time interval between. This always occurs when a condenser's considerable capacity is charged by means of comparatively small machine. If the rate of supply and dissipation are not widely different, then the rushes of current will be quickly succession, and this the more nearly equal both the rate are until limitation incident to each case as depending upon a number of causes are reached. Thus, we are able to obtain from a continuous current generator as rapid a succession of discharges as we like. Of course, the higher the tension of the generator, the smaller need to be the capacity of the condenser. And for this reason, principally, it is the advantage to employ a generator of very high tension. Besides, such a generator permits the attaining of greater rates of vibration. The rushes of current may be at the same direction under the condition before assumed, but most generally there is oscillation superimposed upon the fundamental vibration of current. When the conditions are so determined that there are no oscillations, the current impulses are unidirectionally, and thus mean is provided by transforming a continuous current of high tension into a direct current of lower tension, which I think may find employment in the arts. This method of conversion is exceedingly interesting, and I was much impressed by its beauty when it first conceived. It is ideal in certain respects. It involves the employment of no mechanical device of any kind, and allows to obtain currents of any desired frequency from the ordinary circuit direct or an alternating. The frequency of the fundamental discharge, depending on the relative rates of supply and dissipation, can be readily varied with a wide limit by simply adjustment of these quantities and the frequency of superimposed vibration by the determination of the capacity, cells, induction, and resistance of the circuit. The potential of the current again may be raised as high as insulating. It is capable of withstanding safety by combining capacity and cell induction by induction in a secondary in which need had but comparatively few turns. As the conditions are often such, the intermittence of oscillation does not really establish itself, especially when a direct current source is employed. It is of advantage associated in an interrupter which there are, as I have sometimes indicate, the use of an air blast of magnet or other such device. Readily and bang, the magnet is employed with a special advantage in the conversion of direct current and is deemed very effective. It is primary source in alternating current generator is desirable, as I have stated on another occasion that the frequency should be low and that the current forming there are be large in order to render the magnet more effectively. A follow such discharge with magnets which has been found convenient and adopted after some trials in conversion of direct current, particularly in illustration figure 166, are the pole pieces of a very strong magnet which is excited by a coil C. The pole pieces are slotted for an adjustment and can be fastened in any position by a screw. The discharge rod signed down on the end in order to allow a closer approach of the magnetic pole pieces pass through the column as brass and are fastened in position by a screw, spring, and collars. Are slippery in the rod, the latter serving to set the point of the rod at a certain suitable distance by means of screws, and the former to draw the point upon when it is desired to start the arcs. One of the large rubber handles is taped quickly with the hand, whereby the point of the rod are both in contact but instantly separated by springs. Such an arrangement has been found to be often necessary, namely in case when the EMF was not large enough to cause the discharge to break through the gap. Also when it was desirable to avoid short circuits of the generator by the metallic contact of the rod. The rapidity of the interruption of the current will with a magnet depend on intensity of magnetic field and on the potential difference at the end of the arc. Está hablando de este. Este es el dibujo que él miente aquí. No lo pongo bien porque ese es. The interruptions are generally in such quick succession as to produce a musical sound. Here ago, I was observed that when a powerful induction coil in the discharge between the poles of strong magnets, the discharge produced a loud noise, not like a small pistol shot. It was vaguely stated that the spark was intensified by the presence of magnetic field. It is now clear that the discharge current flow from some time was interrupted a great number of times by the magnetic, thus producing the sound. The phenomenon is especially marked when the field circuit of a large magnet or dynamo is broken in a powerful magnetic field. When the current through the gap is compactly large, it is of advantage to slip on the point of the discharge rod pieces of very hard carbon and let the air play between the carbon preserve the road, and besides has the advantage of in keeping the airspace hotter, as the heat is not conducted away quickly through the carbon. And then result is that the smaller EMF in the R gap is required to maintain a succession of discharges. Another form of discharge which may be employed with an advantage in some cases is illustrated in figure 167. In this form, the discharge rho dd passes through perforation in a wooden box which is thicker, coated with mica on the inside as indicated by the heavy line. The perforations are provided with mica too and some thickness, which are preferably not in contact with the rod. The box has a cover on which is a little larger than the center on the outside of the box. The spark gap is warmed by a small lamp containing in the box. A plate above the lamp allows the draw to pass only through the chimney on the lamp. The air enters through holes in or near the bottom of the box and following the path indicated by the arrows. When the discharge is in operation, the door of the box is closed so that the light of the arc is not visible outside. Ya esto que está hablando él de esta cosa. It is able to exclude the light as perfect as possible as interfere with some experiment. This form of discharge is simple and very effective when properly manipulated. The air being warmed to a certain temperature has in insulation power impaired. It becomes dialectically weak as it were, and consequence is that the arc can be established at a much greater distance. The arc should, of course, be sufficiently insulated to allow the discharge to pass through the gaps disruptively. The arc formed under such conditions, when long, may be made extremely sensitive, and the weak draw through the lamp chimney is quite sufficient to produce rapid interruption. The adjustment is made by regulating the temperature and velocity of the draw. Instead of using the lamp, is answered the purpose to provide for the draw and warm air in other way. A very simple way which has been practiced is to enclose the arc in a long vertical tube with plates on the top and the bottom for regulating the temperature and velocity of the air current. Some provision has to be made for deadening the sound. The air may be rendered dialectically weak also by rarefaction. Discharge of the kind has likewise been used by me in connection with a magnet. A large tube is for the purpose provided with a heavy electrode of carbon or metal between which the discharge is made to pass. The tube being placed in the powerful magnetic field, the exhaustion of the tube is carried to the point at which the discharge will break through easily, but the pressure should be more than 75 millimeters, in which the ordinary thread discharge occurs. It's another form of discharge combining the features before mentioned. The discharge was made to pass between two adjustable magnetic pole pieces, the space between them being kept at elevated temperatures. I should be remarked here that when such an interruption device of any kind are used and the current are passed through the primary or the reactive discharge coil, is not as a rule of advantage to produce numbers of interruptions on the current per second greater than a natural frequency of vibration of the dynamo supply circuit, which is ordinarily small. It should also be pointed out here that while the device mentioned is connection with the disruptive discharge are advantageous under certain conditions, they may be sometimes a source of trouble as they produce intermittencies and other irregularity in the vibration, which it will be very desirable to overcome. The user are glad to say it is beautiful methods, conversion, and effects which fortunately is now vital and which I have been gradually overcoming. I will best call attention to these effects and indicate a fruitful line of work by comparing the electrical process with a mechanical analog. This process may be illustrated in this manner. Imagine a tank with a wide opening at the bottom, which is kept closed by a spring pressure, but so that the snaps suddenly when the liquid in the tank has reached a certain height. Let the fluid be supplied to the tank by means of pipe feeding at a certain rate. When the critical height of the liquid is reached, the spring gives way and the bottom of the tank drops out instantly. The liquid falls through the wide opening and the spring reasserting itself closes the bottom again. The tank is now filled, and after a certain time interval the same process is repeated. It is clear that if the pipe feeds the fluid quicker than the bottom outlet is capable of letting it pass through, the bottom will remain off and the tank will still overflow. If the rates of supply are exactly equal, then the bottom leaks will remain partially open and no vibration of the same, and the liquid column will generally occur through it may is started by some means. But if the inlet pipe does not feed the fluid fast enough for the outlet, then there will be always vibration again. In such case, each time the bottom flag up and down, the spring and the liquid column is reliability of the spring and the inertia of the moving part are properly chosen, will perform independent vibration. In this analogy, the fluid may be likely to electricity or electrical energy, the tank to the condenser, the spring to the dielectric, and the pipe to the conductor through which electricity is supplied to the condenser. To make this analogy quite complete, it is necessary to make the assumption that the bottom each time is give way, is knocked violently against a non-elastic stuff. This impact involving some loss of energy, and that besides some dissipation of energy, result due to frictional loss. In the processing analog, the liquid is supposed to be under a steady pressure. If the pressure of the fluid, by assuming to vary rhythmically, this way will be taken as corresponding to the case of an alternate current. This process is then not quite as simple to consider, but the action in the same is principle. It is desirable in order to maintain the vibration economically to reduce the impacts and frictional loss as much as possible. Y los quedamos.